Hey guys, Adam here with another Punch-Out Repair. This one actually, I don't know if I'm going to be able to do this both in one video, but I have two boxes here. This is from ginch66, I believe, over on KLOV'er. One of these, I believe, holds a Punch-Out, and the other one holds a Super Punch-Out. Who knows which is which. But before we dive into that, I don't know if you guys can tell, but hopefully my video quality is a little bit better. And so I got a lot of suggestions on YouTube and through KLOV'er and whatnot that it might be time to get a better camera. And so I've done just that. And so what I thought I would do is just kind of recap where we've gone over the years with respect to cameras. I'm pretty cheap when it comes to anything actually. And so my plan was just to use the minimum to record these videos and whatnot. And so over the years I've gradually gotten better. But so anyway, when I first started recording years ago on YouTube, this is what I used, and this is, I believe, what the Flip. Back in the day, Flip made these little cameras that were nice, and they could, just upload directly to YouTube and all that kind of stuff. And so I ended up getting this as a Christmas present and used it for many years, actually. So I think this only records in 480p. And so if you go way back onto my YouTube channel, actually my other YouTube channel that I use to record my videos is AJCRM125. And so you'll find a lot of repair videos on there using this camera, actually. And so you'll see the resolution is kind of small, but I mean it worked pretty well for doing what I needed to do and whatnot. Served me well for many years. And then finally I wanted to go to HD, and this didn't do HD. There was a Flip model that did do HD, but I figured if I was going to invest in another camera, maybe just find something else. And I think at that time these guys were kind of going out, I think, of business. I think Creative owned these guys, same makers of the sound cards and whatnot. So anyway, so I jumped to this. I did some Googling online and found out that a lot of people like this. This is the Sony Vado, and there's a couple of versions of this. I think this is the first generation. And this does do HD. It does 720. By the way, both of these do, I think the maximum is 30 frames a second. So this will do 720p at 30 frames per second. And this is what I've been using to record my videos up until this video. And so I've done all my my Arcade Repair 101 series with this camera. All the repairs today have been done with this camera, and this is actually a pretty sweet camera. The only thing I don't like about it is, and the second generation actually corrects this, is that it's touch sensitive. And so I notice that sometimes when I'm trying to press record to stop the video, or if I'm just holding it and my thumb happens to rest right here, I'll end up zooming in or out when I don't intend to, and those sort of things. And so yeah, just little caveats with this. One thing I do like about it, actually, and I've used this in my socket repair video, is you can just go on to like eBay and buy these little Chinese lens extenders. And so I have like a macro lens and a micro lens or something like that, fisheye lens and whatnot. But that allowed me to do the really, really close-up views when I was working with the soldering, like how to get the solder out of the holes with the solder sucker and all that stuff. That was done with this camera using a nice little magnifying lens. And so I think I actually will keep this around in case I need to get really close. This camera is nice. It can get very close. In fact, for like schematics and stuff, let me just turn this off. For schematics and stuff, I was...
Back to normal, got the native cables on here and everything.
Anyway, let me turn this off. So yeah, I was actually checking earlier, like for schematics, that was probably the biggest complaint. People were saying, they can't read the schematics. Schematics are blurry. I've been playing around with this a little bit, and this guy can get really close. It automatically detects when I'm within a few inches or whatever, and then gets in really, really close there, so you can see pretty much everything that I'm seeing, which is awesome. That's kind of what I wanted, was that when I'm explaining things and pointing to things, you guys can see exactly what I'm seeing. And so anyway, long story short, I'll probably hold on to this in case I need it. This I'll probably give away to a friend that also is getting involved in YouTube now. And I think I'm going to stick with what I have. So what I have is actually the Sony, no, not Sony, it's a Canon Vixia HFR 600 that I picked up, and it seems to be working well. I'm not in the highest definition that it can do, only because I don't feel like rendering my videos for an hour and a half. But it seems to be working pretty well here. So anyway, let's pop open one of these guys. Well, actually both of them. I'll probably start with the Punch-Out, and then we'll move on to the Super Punch-Out. And so let's get started. Alright, so let's start with Punch-Out here. And if we fire this guy up, this is kind of awkward because I have to hold the camera with my right hand. I'm used to pointing with my right hand. Alright, so it's doing something. Let's check the other screen. Nothing. And let's just wait for a second to see if it transitions, and it's not. So it's kind of stuck in this mode here where it just shows the Nintendo logo at the bottom. and that is it. Now, one thing I did spot is, let me turn a light on here, I don't know if this helps, is, you know, obviously the batteries leaked out on this one, and that's kind of common. But what sucks is it usually takes out these dip switches over here and then actually works its way into, where's my hand, into the connector, and can mess up, you know, corrode the wires. And I believe, let me just pull this off here. It looks like it's worked its way down to the edge connector. Can you guys see that too? Yeah, actually I can pull this off since I powered off the board. But you can see here it actually starts taking out the edge connector and stuff. And so, you know, this I believe is the video section, so we'll have to look at that and make sure that there's nothing damaged there. It can also work its way in this direction and take out, this is for speech, I think. Actually, well, I forget now. One of these is speech and one of these is music. Actually, I think that's music now that I'm looking at it, and that's speech. And so it can take out the ROMs, and if it keeps going, it'll take out the speech processor, and then you got all sorts of problems. I don't think that we've gotten that far, but I'll probably have to replace or take a look at some of these dip switches and some other things going on. But anyway, my guess right now is there's issues on the CPU board. So what it looks like it's doing to me is that, let me plug this back in real quick. So the game is booting, it's getting to this point, and then it's just stopping here. And so that to me means it's a CPU issue. And so what I probably will do is, you know, before I go ahead and throw the fluke on, I will just grab my logic probe and check the enables to these ROMs. Now, depending on how far the code gets, it may not toggle all of them, but just, you know, poke around and make sure there's nothing floating and nothing that's, you know, just looks suspicious. And then from there, I probably will have to put the fluke on, and I can do signature checks on the ROM. If you don't have a fluke, you can obviously pull the ROMs out and just, you know, check the ROM contents on your ROM burner. But I probably will have to use the fluke anyway for other issues if they come up. So I'll probably just use the fluke to do signature checks and whatnot. So actually, as I was putting it back in and rebooted it here, it actually did get a little bit further. So you can see it's actually got the two screens up. But at this point, I believe, yeah, see, so at that point it's supposed to say, I think, give you the little Glass Joe demo, and it's not doing that. And I'm seeing like sporadic characters and stuff popping up over there. And so it's definitely a CPU issue. So first thing you want to do, of course, is just reseat everything, because it could just be, you know, poor connections with the ROMs and their sockets and whatnot. If that doesn't take care of it, then we can do ROM checks, make sure the ROMs are okay. And if we still have issues, then I'll have to throw the fluke in and start probing into the address bus and figure out what's going on. So why don't we just start by reseating everything, and then basically, you know, checking the ROM contents and whatnot. So one thing I noticed is, you know, the game will get, I've just passed, but it gets as far as the screen where it shows you, I think, the high score table, and it's just about to say, ladies and gentlemen, Glass Joe. And I remember in a previous video having issues with the speech processor not acknowledging the CPU, because he sends cues to this guy, say, hey, can you play that snippet that says Glass Joe for me? This guy's like, sure, and they talk back and forth, because when he's done doing the speech sample, he'll let him know so that he can move on to other sections. So I happened to take a look at this chip, and pin 1 is over here when it should be up here. You can see that on like some of the other parts and whatnot. There's the pin 1 identifier over there, and all these, you know, TTL packages have, you know, it shows you where the top of the IC is, and there's the little notch there. So this guy isn't backwards. Now, I don't know if that thing's damaged or what, but let's go ahead and flip him around, and we'll see if the CPU can get a little bit further. Alright, so our orientation is fixed there. Let's turn this on and see if we can get any further. So that's pretty much the same. No sound or music. We'll let this play through a little bit and see if we can make any progress. Just looking over my shoulder here at the rest of the chips to see if any others are plugged in backwards, and they seem to be okay. This should have moved on by now, I would think. So I think we probably still got issues. Alright, so anyway, reseated all the ROMs, so let me go ahead and just go through them all and make sure the contents are good, and then we can go from there. Okay, so one other discovery here. So what I did obviously is hook up the fluke and to do signature checks on the ROMs, which is basically the same as throwing it in your ROM burner and checking the contents. And I have my little cheat sheet here that tells me what my signatures are if I'm doing Punchout versus Super Punchout. And what I found was that bad, bad, good, good, bad. And as I looked closer, Hopefully my camera can pick this in. Not bad. So do you see the little stamps here? The two guys that are passing, they have an E on them. And these guys have an E-1. Now, I don't know if that means that this is a different revision than these. But it would make sense why the signatures would be completely off. And it would also make sense why this thing would be not booting properly. Because depending on how the code is written, maybe, you know, what's in here, the program contents that's in here is not compatible with what's going on in here. And so I think what I'm going to do is basically throw them in my ROM identifier, figure out, you know, the stuff that's in MAME. It's either, you know, version E or E1, one or the other, but they all got to be the same. And so basically I'll take all of these over to my ROM burner and then figure out what version MAME has and just make them all the same. Make them all the same version. That way I know that we're dealing with something that should boot right off the bat and get us where we want to be. Alrighty, so we're back over at the desk here, and I need to select a manufacturer. This is just the lab site programmer that you guys have probably seen me use before. I got a ton of programmers, and this one actually works pretty well. The only disadvantage is it's got a parallel port cable that runs all the way down to this old Windows 98 machine. It'd be nice if it was serial or a USB or something, but this is what we got to work with. So anyway, we gotta choose a manufacturer, and I thought I would just go over this real quick because some of you guys might not know this, but you know, obviously a lot of these parts don't have the manufacturer stamped right on here. In other words, it doesn't say Hitachi or Texas Instruments or whatever. What you will find is if you zoom way in, and hopefully my camera can do this, if I just hold it here for a second, there we go. So you'll see that little symbol there, that little circle or whatever. That's the IC logo. That's the manufacturer's logo that they will stamp on these parts. And so what good does that do you? Because that doesn't really tell you anything. But what you can do is you can go online, some of these websites, like this one here, for example, what's it called? Elnec. And so you can basically identify the manufacturer of your part by comparing a logo. And so if I go over here and say by logo, then let's see what happens here. So we get a whole bunch of logos. So what you can do is kind of pan down and see if one of these logos catches your eye and compares to what you have. So that's one website. Actually, boom, there it is right there. Can I zoom in on this? That's the one we're looking for right here. And so that, let's see, does it tell me? If I click on that, boom, that is a Hitachi. Okay, so that's one website. Looks like elnec.com. And then if you just Google, you'll find it. Here's another one that kind of does the same thing. It just gives you a whole list of logos alphabetically and what they are. So if we scroll down to H, and there's the same exact logo, Hitachi, right there. And so this is very helpful for me when I can just get if I just see a logo and no other identifier aside from a few numbers, at least and can know what the manufacturer is, and I can kind of go from there. All right, so let's throw these guys in here and let's see what's what. So we went ahead and reburned all these guys. This guy actually, after erasing him, I couldn't get him to program again, so I just grabbed another one from my stash. And hopefully that will get us a little bit closer here. Okay, that is the bottom monitor. And let's see the top monitor. So I'm missing some colors, obviously, because I just see red and blue, so there's no green. Oh, we still got CPU issues because it's just reset or something's going on there. Still no green. Okay, so there's probably something still squirrely going on with the CPU PCB. Wow, that is weird. It's like going super slow. Okay, that looks alright. That looks alright. I'm guessing the green is from the edge connector because, like I said, the acid kind of went in there and wreaked havoc on that connector there. So I probably just need to reseat that, clean it all up. We'll probably get our green back. Oh, good. So we're at Glass Joe. And this is looking promising. Okay, but his position is off. So on the video PCB, there's a register or set of registers that dictates the position that Glass Joe or any of your opponent actually is going to be. And it looks like that is off. And so I've seen that multiple times. Actually, if you take a look at some of my other videos, you've probably seen it happen on those too. And so I think I know where to take a look to fix that guy. But let me start with the edge connector, the little ribbon cable here. See if we can get our green back, and then that way we can see all of our colors. So these are the color proms according to the schematic here. And what I'm noticing is this is the green for the lower monitor, this is the green for the upper monitor. Let's pick another one like that. I think this might be like red or something. And so you can see these are the 4 output bits that dictate the color, and they're all wiggling nicely. The one for green is high all the time, and I think this is like the green for the upper monitor, also high all the time. That's really coincidental, but I think we may have an issue here, because if I probe any of the other color proms, they seem to be doing what they need to do. So this is kind of an obscure part, but I think that I do have some on hand because of another punch-out repair that I did. So why don't I start by reburning some green proms here, and we'll see if that can get us our green back. Okay, I got our new color proms in there, 8E and 6F, which are green for both upper and lower. Let's throw this guy on. There we go. So that looks much nicer. I see a green glove there. Let me switch over to the upper monitor, and no green. Now actually, yeah, so this connector here, I suspect, has got some acid damage, because, you know, that looks good, and then we lose our green back and forth. And so I'll have to address that in a little bit, but I think we're probably, from a logic perspective, in good shape. Here's the lower monitor. Let's see what the main screen looks like. That looks so much better. Yeah, there's definitely some issues here with this connector, because it's got sync stuff going on. You can see a little bit of waviness there. But our player looks good. He's got green, which is the way he's supposed to be. So the only issue left to address, aside from the edge connector there, is the position of Glass Joe. And the CPU decides where they want to put Glass Joe through a set of registers on the video PCB, which is this big one here. And I think we've seen this issue before on other board sets. I know I have. And so if we look at the video PCB schematics, there's a set of registers over here. This is kind of what the CPU dictates as far as vertical and horizontal position for Glass Joe, or any of the opponent actually. I see HS here and here, so that's probably your horizontal position, and then I see VS here is another register, that's probably your vertical position. So my guess is it's one of these two guys here. Could be a bit that's stuck low or high or something like that, and so the CPU is trying to tell it, hey, I want you to be over here, and that number is off by a little bit, and so he's over there. And so that hopefully that should be a quick fix. So let me throw on my ribbon cable so I can open this up, and we'll start probing around those registers there and see if something is off. So here we have the board laid out on the bench. You can see I got the ribbon cable so I can open her up, and right away the first thing I notice is that there are sockets all over this thing. But I can understand why. When you take a closer look, you can see that there's a lot of damage to the copper here, and there's all sorts of pitting going on and other stuff. And so I don't know if this thing was in a moist environment at some point, or I don't think this was due to the battery acid issue on the other PCB. No, in fact the battery is on this side, so I don't see how that could have caused an issue. Besides, how would the acid get there? But nonetheless, there's a lot of sockets going on here, and hopefully not a lot of damage that I have to worry about. I mean, I do see like pitting and all these traces and stuff. But I mean, we're close, right? Glass Joe is there, the colors are there. It's just that he is not doing what he needs to do as far as position goes. But ironically, you know, this whole area, this section lines up exactly with this section here. These ICs are located in this area. There's registers and a few adders in there that play a part. And actually, as I zoom in here, I'm just looking at this guy right here. Let me zoom in so you can see it. This leg doesn't even look like it's making contact, or is it even there? The leg is not even there. You guys see that? And so, yeah, that's a problem. So I'm gonna have to go through these one at a time and just make sure that, you know, they're solid and that they're doing what they need to do. And so let me just do that, and then hopefully things will improve from there. One quick thing that I wanted to bring to you guys' attention before I tear into this, and I just kind of spotted an issue here, so I wanted to go over something. So 90%, 99% of the parts on these boards, or any boards that really you're working with, are TTL parts, right? And so basically it's just a bunch of little logic gates. However, the people who make those, let's zoom in on this one that I just pulled out, for example, Texas Instruments, they make different versions. And so you can see here the 74 LS283. So 74 is just, you know, it's the prefix for TTL, And then you've got the 283 at the end, and if you look at your data book, it'll tell you that 283 is an adder or something like that. I believe this is an adder. The LS means low power Schottky. And so there's different families of TTL that Texas Instruments and other people put out. LS means low power Schottky. F, I think, means fast. Sometimes they won't even have it. It'll just say 74 283. So low power Schottky just means that it runs at a lower power than some of the others, other equivalent parts in different families. And most of the parts that you'll see on this game, and any game actually, will be low power Schottky, because if you can fill your boards up with low power versions of those chips, then they will run much lower power. You don't have to worry about burning up your edge connectors or anything like that. However, there are specific cases, and Punchout is one of those, where you might not want low power in certain sections. And so most of these chips, if we take a look at the schematics here, you can see it'll tell you this is an LS, low power Schottky, 161, 161, LS1, was it 377, 273. So these are all low power Schottkys, and that's fine. But this one section in particular, the section that's causing us problems right now, you can see here, they want the fast 283. They don't want the LS 283. Same with that guy there, same with that guy there. And the reason is the timing, right? The clocks that are running and the timing that's going on in this section, they're very tight, and they need things to happen very quickly. And so the engineers, understood that and put in a restriction basically saying we need these parts to be fast parts. So if you don't replace fast parts with fast parts and you replace them with low power Schottky, you will run into timing issues if timing is tight. And this is exactly what I've seen in the past, and which is why I know. That's why I kind of wanted to record this clip. I've seen issues like that in the past. I mistakenly replaced a fast part with a low power Schottky part, and I was chasing my tail for days trying to figure out what was going on, and then I realized, oh, the engineers specifically called for a fast part, and here we have a slower part, low power Schottky. So these parts sacrifice speed for low power, essentially. So anyway, not to ramble on, just wanted to bring it to your attention. So as you're fixing these boards, chances are you won't run into trouble. Like I said, 99% of the parts are low power, but just keep an eye out. Sometimes, they'll throw a curveball your way and you got to actually replace it with a different part. So I replaced all of the problematic LS parts with fast parts as indicated by the schematic. Let's see if we have there we go. So previously this was kind of bouncing all over on the left side, and it's looking much better there. Position looks correct. And this is also driven by the video PCB. So let's let it play through, get the glass gel, and we'll see if his positions have improved. Okay, that's looking better, and you should line up directly with the player. Perfect. Awesome. Let's see, how's the graphics looking on Glass Joe? Pretty good, actually. So I think we're in good shape here. I thought I had seen a little bit of glitching in his gloves. Let me just examine this. Yeah, okay, so I do see a little bit of glitchiness in his gloves, only when he's in a certain position. And so that tells me that it's probably something with the sprite ROMs. If it were every position that he was in, then I would say, yeah, there's definitely, a global problem. Maybe with the serializers at the other end of the EEPROMs that take the data and throw it out to the screen. But it's really just when he's in one particular position, and it's just his gloves. And so I'm betting that one of these ROMs has some erroneous data in it with respect to how his gloves are displayed. And there's really no other way to trace that down than to take every single ROM out and throw it in the burner and to verify them. The Fluke does not talk to any of the graphic ROMs. It only talks to the program ROMs. So I can't do SIG checks with the Fluke or anything like that. It's really just a brute force method of taking them all out and verifying them. So let me do that, and hopefully we'll find out which guy is buggy here. Exactly. So yeah. So out of all the video ROMs, we have one that's bad. It looks like it is, what is it, 4T? So yeah. So that's good. I mean, at least it wasn't a whole bunch. I'll just have to erase it and reprogram it. I don't know why, but this guy put black marker over everything. So I'll probably have to get like rubbing alcohol or something, see if I can clean it up, because otherwise I won't be able to erase it to burn it again. But so yeah, this is the naughty one, the bad ROM. You can almost see the red gloves in there, can't you? No? Alright, maybe it's just me. Alright, let's reprogram this guy and get our gloves back. There we go, that looks better. Let me just play this through a little bit, because I think it was only a couple of frames where his gloves were kind of sketchy there. But it's looking pretty good. So yeah, looks like we got that one ROM. So I flipped it over. I mean, I had confidence that that was what it was, and sure enough, that's what it is. So the only thing I want to check now is the sound. I do believe, if I look over my shoulder here, Attract Music on is dip switch M, which I believe is on here, and I am not seeing any, oh, I'm sorry, I'm not hearing any music, Attract Music, but as you can see, the acid pretty much took out these dip switches, and so I suspect these guys are just toast. You can see they're kind of green and nasty inside of there. What I can do, just to confirm, is to go ahead and coin this guy up. So I will cheat by using my little probe here, since I know I've done this so many times. I know which ones coin it up and which ones start the game. So pin 8 here will coin it up. Oh, beautiful. So I'm hearing music. And let's see if we have speech. So what is it? 20, 19, 18, 17. Oh, I accidentally pushed a different button. Oh, that's interesting. That's cool. Let me try this again. Let's coin this up again. And 20, 19, 18, 17. Make sure I just pressed the right one there. Okay. We'll let this finish up. And then I'll flick over here and see if I can get the speech. Awesome. Okay, so let me search through my stash. I'm sure I have a 8 position dip switch. I'm not sure about a 4 position. But let me just investigate a little bit. Actually, what's the setting here? Free play is on, which is what it's on right now, actually, and it's not on free play, as we saw. And so, yeah, both of these guys are hosed. So let me go ahead and pull those. And actually, now that I look at it too, sorry, I wasn't sure if I was in focus there. So the data from these guys pass through these buffers so that it can get read by the CPU. So these may actually be messed up too. So maybe what I'll do first is kind of just probe around a little bit before I go ahead and pull all this. I mean, I don't know. These got to be pulled anyway. So I'll pull these, probe these, and then, if necessary, replace these guys too. So 1 second while I do that. Here we go, 2 brand new dip switches. Tell you what, let's put it into self-test, which looks like it is P, the last guy over here. And then I believe Punchout will actually tell you what all the dip switch settings are. And let's let it go here. So we got a ROM test, a RAM test I believe we just missed. Okay, cool. So all the switches are off except for the test, which is on, okay? And so let's turn the music on. That is dip switch M, I believe. And yes, so music is on. So let's take it out of self-test. We'll reboot this guy. And hopefully we will have our Attract. There we go. Excellent. Let's coin it up once again. Just make sure that we didn't mess anything up. And 20, 19, 18, 17. Should be counting down. And we'll just check our speech. But I have high hopes that we are all set with this one here. Oh, let me flick it over to speech.
Ladies and gentlemen.
Okay. Awesome. So yeah, I think we finally took care of all the issues on this one. So what did we see? We saw some video issues. Well, first we saw CPU issues. Took care of those. Then we had video issues, and then finally getting the I/O set up with the dip switches and all that good stuff. So I think we are done. You guys like this stuff? I mean, I suspect that you do if you watched it this far. So if you do and you haven't subscribed, go ahead and subscribe, and that way when I do videos, you guys, or repairs I should say, you guys will be the first to know. And I do have another couple projects in the queue that I want to dive into. So yeah, I'm actually excited to get started on those too. Not board repairs, but other stuff that you guys might be interested. So anyway, if you're into that, go ahead and subscribe. And I think you can find me on Twitter now too, One Circuit, so you can follow me there. other than that, I think that's it for this one, guys. So God bless. Thanks for all the kind comments and emails and everything, and we'll catch you on the next one.